This question asks you to arrange some ionic compounds from smallest lattice energy to largest lattice energy, and explain how you did it. After you've read the question, plan your approach. For this question, the key fact that we need to recall is that lattice energy increases as charge on each atom increases, and distance between the atoms decreases. Based on these criteria, we'll examine each of the compounds and arrange them accordingly. It's never a bad idea to have the periodic table on hand when you're asked to compare a series of compounds, so let's pull out the part we need. Okay, now to solve the problem. Since we know the order will depend on the charges involved, start by assigning a charge to each atom. Looking at the periodic table, we can see that sodium, chlorine, and fluorine are all one column away from the noble gases. That means their tendency is to form ions with a single charge. Fluorine and chlorine need one electron to become isoelectronic with a noble gas, so they become negative ions. Sodium must lose an electron to obtain a noble gas configuration, so it becomes a positive ion. Magnesium and oxygen are both two columns away from the noble gases, so magnesium will likely form a 2+ charge, while oxygen will form a 2- charge. Now put the compounds in order from smallest to largest lattice energy. If we write out the reasoning as we go along, it'll save us some time and make it less likely that we miss something important in our explanation. Magnesium oxide has charges of -2 and +2, whereas the other two compounds only have -1 and +1 charges. This means there is a much stronger attraction between the magnesium and the oxygen ions. Since lattice energy increases with charge squared, magnesium oxide will have the greatest lattice energy. Sodium chloride and sodium fluoride each have a -1 and +1 charge, so we'll have to consider the distance between the ions. Ion size increases as you move down the rows of the periodic table. Therefore, the fluoride ion is smaller than the chloride ion, and the distance between the ions in sodium fluoride is less. So NaF has less than magnesium oxide, but more than sodium chloride. Check that you arranged them from smallest to largest, and you're done.